All right. Hello, everybody, and welcome to the next sort of streaming session that we have going on here. So, on the agenda today, we've got a couple of different things that I want to discuss first, and then we'll jump right into things. So, the very first thing that I want to touch on is that I'm going to be sort of scheduling out streams going forward. So the plan is to stream on Wednesday nights at 9 p.m. Eastern Standard Time. And occasionally I'll probably also throw in a stream on Thursday nights. If I've got something extra I want to tackle that week or I have the ability to do it, I'll do that. There may be random streams thrown in during the week or maybe on the weekend if I've got extra time. But for now, I'm just going to say that Wednesdays are going to be the day that we're going to be streaming. So that's the first point. The second point is one of you actually brought up in the comments on the YouTube version of this that it might be better if I switch the camera down here in the lower portion of the screen to instead point the other way. So I'm going to try that real quick, and you guys let me know what you think. Let's see, where is it? Flip. Horizontal. Reason being is, it seemed like I was looking off sort of away from the frame, which I can see makes sense. That means that some things will be backwards, like this Secret Lab text back here will be backwards in the stream. As well as I might get, if I'm looking at the camera and describing things, that might actually, cause that to be reversed on occasion. One thing I'll just check real quick. I'm only going to reverse it for this view. For the full screen camera, it's still going to be facing sort of the same direction there. So just a quick little adjustment there. All right. With that, for any of you who are brand new to this channel or have not seen anything that I've previously done, on this channel we stream the development of a game engine live, and this is based off of a series that I initially started on YouTube about a year and a half ago now, where we are developing a full game engine using C and Vulkan as the rendering backend for now. And we are doing the whole thing 100% on camera from start to finish. And we're going to wind up building a couple of games along the way to sort of prove our tech as we go. And we are sort of in the throes of that now. So we've got a renderer up and running, albeit it's not terribly fancy yet, but we do have some basic things up and running, some basic lighting, things of that nature. And so what I've decided to do this year, different from previously, is going forward, at least I'm going to try this for a while, going forward I'm going to live stream all the development, because what I did before was sort of do a little bit of a planning session off camera, pre-code a lot of the things off camera, and then just sort of plop it on the screen. And it just occurred to me that maybe you guys aren't going to get everything that maybe you could be getting out of that if you actually see my thought process, my debugging processes, places where I mess up or what have you, where I need to sort of step in and debug and figure things out. So that might be valuable to you guys. So I figured I would change things up, and we will go ahead and live stream all the development going forward. That being said, we will eventually be making highlight reels for the engine. So that's another thing I have in the agenda for this year, is to make highlights or dev logs, if you will. And so that's another thing that we're going to be doing. And yeah, so that's sort of the intro. And I guess let's go ahead and jump into what we're going to be doing today. One more thing I actually wanted to mention before we move on is somebody had mentioned a pretty good thing that I should mention or add to the roadmap, rather. And that is volumes. So we need volumes. Oops. Wow, I can't type apparently today. So volumes. And that's three-dimensional volumes, such as pre-computed visibility volumes, which means if anything is, if the camera happens to be within that particular volume, then anything within that volume is rendered, anything outside of that volume is not. Or you could potentially have the opposite of that, where you're saying, well, if you're within this particular volume, anything that is within it should not be rendered, and everything outside of it should be. And so that's one thing that would be a good idea to add. And then also other types of volumes like triggers for gameplay. So whenever you walk into this sort of invisible box in the world, it triggers some event, sends off an event to be fired or something like that. And so that's another one. Also, things like physics volumes would be another one. Maybe weather volumes. So things like particle effects like rain and stuff like that. Or weather occlusion volumes. So that would be like if you have a scene where it's raining outside, and you have an indoor portion of the scene, you might have a volume to say, hey, don't render rain within this volume. Things like that, right? So volumes, that's an extremely important thing to go ahead and add, and I did not have that on the list. So we'll go ahead and get that added. I can't guarantee that that's going to be added anytime soon, but it's definitely something that I don't want to miss on the roadmap. With that said, any features that you guys actually have that you think of, feel free to drop them in the chat. I do check the chat from time to time, and I'll try to keep this as interactive as possible. So if you guys think of anything that might be a good thing to add, feel free to drop it in there, and I'll get it added to the roadmap. Speaking of chat, hello Midnight. Thank you for lurking. I really appreciate that, and Norlin as well. Your brain isn't big enough to understand any of this. It comes with a lot of years of practice, right? We all specialize at different things. This just happens to be the thing I specialize in, right? So, but thank you guys for tuning in and watching. I greatly appreciate the support. All right, so I believe that is all on the agenda that we have. Sort of housekeeping items, right? So the next thing that we're going to do is jump into our discussion of what we want to tackle in this particular stream. And that is something that I've brought up several times, and that is basically our systems manager. So right now, if we take a look at the code here in our engine, we have all these different systems being stood up, right? So we have here the console, the KVR system, events, logging, input, all kinds of things, right? And for the most part, these things kind of follow a similar pattern, right? Where we call the initialize function twice, once to get a memory requirement, and then we allocate some memory for it, and then we call it again with the allocated memory. And so what we really have here is a lot of repeated code. And the other thing that we have here is the engine having knowledge on a lot of these various systems that it doesn't really need to have. And so we're left with this sort of long list in our engine state of all of these various systems that we have in place. And every time we add one, we have to add to this list, and it's just becoming kind of difficult to manage, right? And so what we're going to do is we are going to write something to manage those systems, hence a systems manager. The other thing that I'm hoping to accomplish with this is the elimination of a lot of static variables. So if we do a quick search here for static, right, and I'm just going to do a case-sensitive search. Now we're going to get a lot of false positives in here as well, but we have a lot of things that look like this, where we have a static, some sort of state type, which is a pointer, and then it's called state pointer. And each of these tend to have this thing where we assign it the memory that comes in. Right. Again, this is another pattern that we're sort of following everywhere. And so we want to also eliminate all of these static states all over the place, because one thing that will actually prevent us from doing is if we ever get to the point where we want to hot reload the engine. I haven't decided whether or not I want to do that yet. But this would definitely be something that would block us from doing that. And we sort of want to break away from this pattern of doing this, right? And the only reason we did this is because we didn't have anywhere to sort of store the state otherwise. That was an easily accessible location. And so what we're going to do is we are going to keep that state within the state manager itself. And anytime we need it, we could just reach out to the state manager and say, hey, give me the state for this particular type. So with that, we are going to have registered systems that are by type, and each one of those registered types will have its own sort of state pointer that is accessible. And from there, we can then retrieve the state pointer and operate as we normally would. So we're going to take this one step at a time. First thing we're going to do is we are going to stand up the system manager and get all of this code out of the engine and moved into that. And then we'll go ahead and move all the state code after we have everything up and running. So I can't guarantee that we're going to get through both pieces of that, but I think if we do have a little bit of time at the end of the stream, we'll go ahead and start tackling some of those things. Okay, so we're going to have to do this in a couple of different pieces, right? So one, we're going to have to move all of these state objects. Two, we also have, let's see, where is it? We also have this linear allocator for the systems allocator. We're going to be moving this guy as well because the engine does not need to know about that. It really only needs to be used by the systems manager. So we're going to go ahead and move that as well. And then we're going to define what we're going to call an interface for each one of these systems to sort of align to. And that's basically going to be an initialize and a shutdown and a potential opt-in update. And those will take a standard set of arguments, and they'll basically be, it'll be a struct full of function pointers, essentially, is what it'll wind up being. And when we go ahead and register the type, we will pass along the functions, sort of the functions that will be called, such as the initialize or shutdown. And then within the systems manager itself, we can just use the function pointer in there and not have to worry about those underlying types. All right, so the first thing that I think we should probably start on is going ahead and creating our new files. Now, there are two places that I could create this. One it would certainly be valid to put it in here with the systems. But I'm not going to do that because it manages systems. It isn't a system. So I'm going to put it under core, and I'm going to call this systems manager.h, right? Of course, we have pragma once, and we're going to include defines, .h, all right? And the first thing that we want to do is we want to define what those types are going to look like, right? So we have three callback functions or function pointer types that we want to go ahead and set up. So I'm going to type def these. So the first one is going to be it's going to return a Boolean, so a B8. We're going to call this PFN for pointer function, and then we'll call this system initialize, right? And that one is going to take a U64 pointer for the memory requirement, right? It's going to take a void pointer for the memory, and it's going to take another void pointer for the config. Now, not all of our systems actually have a config. So in that case, what we'll do here is we'll just pass a 0 to that, okay? So the next thing we'll do is type def another function here. This time it's going to be return type void. We're going to call this pfn underscore system underscore shutdown. And this is going to take just a void pointer state. right? And that should be pretty self-explanatory how that's going to be used. And the last one, we're going to, again, return a, oops, I forgot an E there. We're going to return a B8. We'll call this pointer function system update, right? And this one is going to take in void pointer state and F32 delta time. And that's because we're going to wind up needing the delta time, or the frame time, as you might know it, or the difference of time between frames. We're going to wind up needing that in a lot of our systems to actually perform updates. So I'm going to go ahead and pass that there. Note that we may wind up changing this interface at some point to maybe take a struct of some sort so we don't have to refactor it. But for right now, I think I'm going to roll with this sort of format here. There aren't that many systems that actually require this for right now, so I'm okay making that assumption for right now. So the next thing that we need is we need something to represent our individual system. So we'll type def a structure, and we're going to call this, we're going to call it K system. And we're going to call it K system because we don't want to just call it system and have it potentially clash with something else. So we're going to call it K system for Kohi system. This is going to take a U64 state underscore size, a void pointer to hold the state, and then it's going to have a function pointer for initialize. It's going to have a function pointer for shutdown. And it's also going to have a function pointer for, as you guessed, update, right? And this one is going to be optional. So I'm just going to put that in here. A function pointer for the system's update routine called every frame optional, right? All right, so that is the representation of our system. This is sort of going to be our interface that Kohi sort of works with, right? The systems manager is going to interface with this. The next thing I'm going to do is I'm going to set up the system manager state, I think is what I'm going to call it. So what that's going to be is basically an array of these guys. Which before I actually set that up, let's go ahead and define a couple of system types, right? So let's go ahead and also type def an enum. God, I keep missing the E here. An enum, we'll call this K system type, right? And here we're just going to define some, the way we're going to do this, we're going to define some known internal system types, and then we're going to leave a section of this open for user space so that if the user wants to define their own systems, they can do that, right? There's going to be some that the engine knows about, and there's going to be probably a lot more that the engine doesn't know about that'll be implemented through plugins and things like that. So we definitely don't want to make too many assumptions there. So we're going to basically prefix everything here with a K system type underscore. I'm just going to copy that. And the very first thing we're going to do is the memory system. So we're going to set that to 1. An important caveat here, though, is if we take a look at the engine, we do go ahead and set up the memory system here. However, the memory system has to be stood up before anything else can be stood up, and that's including the systems manager, because this basically sets up our massive pool of memory that we allocate everything from. And so this is sort of a special case system that is not going to be treated the way that the other systems are going to be treated. So Essentially what this is going to wind up doing is we are going to pass in the memory type, the memory system type, but we're not going to pass in an initialize for that, only for that one. It's required for everything else. And then we are basically just not going to have that be a type that gets registered in the traditional sense, right? So that is the memory. And in fact, what I'm going to do is, let me get rid of that file view, and I'm going to split this to the right. Actually, I want this one over here. And what we're going to do is basically go through and define all the systems that we have. So the next one is going to be console. Whoops. Must have already had caps lock on. So that's just going to be 2. Next is kvars. So that's going to be 3. The next one is going to be events. 4, and so on, right? And in fact, I'm probably not going to define values for all of these just yet, because they might wind up changing at some point. So I'll say inputs, and this will also kind of give me an idea of the order that they're being done in. So the platform is the next one. Resource system. The shader system, which that incidentally might be, we might wind up moving that to the renderer. Because I'm not 100% sure that should be something that stands on its own just yet. So that may be something that I wind up doing in the future. Let's see. So I think that is all of the, no, it's not. We have the job system next. The texture system, the font system, I believe we have the camera system, and the render view system, material system, the geometry system, and I think that's actually all of them. Okay, so we've got that. And then what we're going to do is we'll say case system type known max, and we're going to set that equal to 255. So what that's essentially going to do is it's going to reserve the space between this geometry, which is 16, and 255 for our known internal systems. And that will allow us to have plenty of space to add more systems that are known types. And then anything that is beyond that will be considered user space. So we'll say note anything beyond this is in user space, right? Speaking of user space, the user space will actually wind up having a count of its own. So, or a max of its own, rather. So I'm going to go ahead and define that up here. And I'll show you why I'm going to define this in a second. But we're going to call this K-system type max count. And we're going to set that to, I'm going to set it to 512 for now. We might want to bump that up later, but I think 512 is going to be sufficient for now. So the next thing we'll want to do here is we are going to have a K-system type user max, and we're going to set it equal to that K-system type max count, right? And this is going to be the user space max, right? So that's the amount of systems. This minus this is basically how many systems the user can have. And then we're also going to define one more, which is going to be system type max. which is sort of a max for the whole thing. So we're going to basically alias this user max, right? And we're going to say the max, the max including all user types, user space types, we'll call it, right? And that will do our system types for now. In fact, I'm going to get rid of these for now. We just need to know that we're starting at 1, not 0, right? And these will auto increment as we go. So, all right. By the way, let me just stop for a quick second. If you guys have any questions on any of this stuff, feel free to, drop it down in the chat, and I'll do my best to answer it. Because the whole purpose of this is sort of to be a little bit interactive. So please jump in with any questions that you guys might have. Okay, so that is our defined system types. So the next thing I'm going to set up is another type def, another structure. Whoops. Autocomplete is my enemy today, apparently. And I'm going to call this K. Actually, you know what? I'm going to call this System Manager State. All right. And this is basically going to be the state for the system manager. And we're keeping this public so that we can troubleshoot and debug this very easily. I could make this private by moving it into the C file, but for now I'm just going to leave it here and keep it public. That'll also allow me to easily allocate enough memory for it within the engine code and not have to worry about calling something twice. So in this case, I'm just going to keep an array of case systems. So this is going to be systems. And what we're going to have here is this max count. Whoops. And actually, I don't really have a reason to start this at 0. Or at 1, rather. 0 should be fine. Because these 0, since we're going to use this for array indexing, let's go with 0 here. Yeah, that makes more sense. Okay. So, for right now, our system manager state's going to be pretty straightforward like that. There's not a whole heck of a lot to it. All right, it's just basically a container for all this stuff to sit in. Let's go ahead and define our interface for that. So it's going to be systems manager initialize, and this should be systems manager state with an S. We'll also have a void systems manager shut down. All right, and we'll also do a B8 systems manager update, and this is going to receive a U32 delta time. All right. And that is basically going to be called every single frame by the engine. And then any systems that are opted into the update cycle will, of course, receive a update call. And then finally, we need a way to register a system. And we're not going to worry about unregistering a system because I don't really think that makes sense in terms of the way a game engine would run. I can't see any circumstance where you'd want to unregister or shut down an individual system. So we're not going to do that. But what we are going to do is systems manager register. All right. And this is going to take we're going to say a U16 type. And that is basically going to map to this guy, right? Which U16 will be more than enough to hold this. And we're not using an enumeration type here because user space will not have access to override this. So they'll have to declare their own enumeration and specify values between here and here, right? So we'll call that a U16 for the type. I'm going to come up here and copy these down here for the arguments, right? And then just replace these with commas. That way we have those. And then we're also going to pass in a void pointer config for the system. So this essentially is going to wind up registering the system and then passing along the configuration to initialize the system, right? And so that is the way that that is going to work. So I think that is our entire interface there. So I'm going to copy these guys and go here and create a systems manager C. And of course we need to include systems manager H, and we'll paste these things in here. Okay. And let's see, how do we want to, let's get rid of that. So we really need to stand up the systems manager all the way at the top here, right after the memory system. And probably, I suppose we could do it after these guys, after the game state, after the engine state. Yes. In fact, let's go ahead and add. We need to actually add the state here to the engine state. So let's go ahead and include core systems manager, right? And we'll have systems manager state, and we'll say sys manager state, right? So that'll be there. This is another thing, the linear allocator, we actually need to need one of those in the system manager state, actually. So we're going to have to put that here. Yeah, we'll go ahead and put that there. Of course, we don't have linear allocator, so we'll need to include containers. Whoops, not containers. Memory linear allocator. So that way we have that here. And then we will just mark that to be deleted. And I'm not deleting this yet because we're going to move over a couple systems at a time and just make sure things work. And we'll do some sanity checks along the way. All right. Why is this still bleating? Linear allocator is undefined. Well, that's rubbish. It finds it here. Must just be tripping. All right. So I guess the next thing that we have here is we go ahead and set up the engine state with a kallocate. That's going to make sure that everything is zeroed, so we shouldn't actually have to zero out the system state or any of this either, because that's going to be included on there. So this is going to be the next step, actually. So we'll go ahead into the C file and initialize. We'll go ahead and add that there. One thing, our initialize and shutdown, as well as update, actually, are all going to need, they are all going to need the state. So actually, we are going to have to modify this a little bit. So we need to pass in a pointer to the state, which is held by the engine. So we'll modify that there, modify that here. So that way we actually have all of that. This is going to be state systems allocator. Systems allocator total size. I guess that's fine, but don't we have a... Yeah, we have a megabytes function. Let's go ahead and use that. Because that should essentially give us the same thing as what we're dealing with here. So let's clean this up a little bit and be a little bit more explicit as to what we're dealing with here instead of doing that inline multiplication. In fact, we don't even need to do this. We can just do it in line. Okay, so there's that. All right, so the next thing that we're going to have to do is for each one of these that we move over, we are going to have to make sure that it fits the sort of structure that we have in order to register it, right? So the setup for this is basically going to be register known systems, and then the registered system is actually going to initialize, let's see, we'll say call initialize, allocate memory, and then call initialize again with allocated block. Right, and we're going to do that in a sort of standardized way. Which means the systems manager register probably ought to have that state as well. Which will be easy enough for known types, but not necessarily unknown types. Okay, so I'm going to require it for now. And then we may have to make an adjustment on this later when we go to extend this into user systems. Yeah, I think I'm okay with that for now, though, because I could always just expose it from the engine if I need to. All right. So, what do we have here? So we need the state. So the first thing we're going to do is probably go ahead and create a case system. And we'll say system.initialize equals initialize. Right, we'll assign our function pointers. We'll say shutdown equals shutdown. Update equals update. And then once we have those, we'll say if system.initialize. We will go ahead and call system.initialize, right? And we will pass the address of system.state size. So that's going to be the memory requirement there. We'll pass 0, and then we'll pass config, right? And we'll need to check the results of that. So if that fails for some reason, then we'll probably want to log something out. So we'll go ahead and include core logger, and we're going to treat this as an error. Failed to add, it's failed to register system. Initialize call failed. Right, and the system itself will probably give us some sort of data on that. So since this returns a Boolean, we can go ahead and kick out here, say return false to indicate an error there. Otherwise, in this case, if we do not have a system.initialize, then we also need to check to say, hey, is the type equal to k system type memory, because that's the only one that we're going to allow to not have an initialize. So if it's that, it's fine. You know what? Actually, let's say if it's not that, then we're going to throw an error saying initialize is required for types except, and we'll just copy pasta this. All right, and return false. Okay, let me scooch this over a little bit. All right, let's see here. Let me actually move these guys over here so that I don't run into potentially having you guys looking behind the camera here, because that wouldn't be any good, right? All right, so the next thing we probably ought to do is, so we've got our memory requirement here. So obviously we need to perform our linear allocate, right? So I'm just going to copy this line here. Right, and we're going to say that the system.state equals the result of this. So we need the state systems allocator, and we are going to need the system dot state size. Okay, so we go ahead and allocate our state for that, and then we're going to go ahead and call initialize once more. So initialize, this time we are going to pass in system.state as well as the config. And once again, we will go ahead and bleat about it if that fails for some reason. All right, so let me just see here. So we have our initialize call done. That should be everything that is needed to actually register. So if we get all the way to the bottom of this, should be able to return true, no problem. All right. So registering known systems. This is probably something that's, while I could do it in line here, is going to make this file kind of messy. So I think probably the way I'm going to do this is let's do a B8. Let's do a static, actually. Make it private to the file. Register known systems. Right, and this is going to take the state, because we need that. And this is just a forward declaration, right? And so we'll take this, go down here, and implement it. And we'll say return true if we get all the way to the bottom of that. And then in our systems manager initialize, we will just call register known systems, passing along the state, and I think we can go ahead and just return that. Whoops. I don't think there's anything we're going to have to do after that. So that should be relatively straightforward. Okay. Before I forget, in the engine itself, we should go ahead and stand up the systems manager itself. So we'll say systems manager initialize. We're going to pass the address of engine state. Oops. Engine state. System manager state. There we go. And then we'll obviously have to check that to see if it fails. Throw an error if it does. So systems manager failed to initialize the boarding process, right? And we are actually going to return false here. And I'm actually going to make this K fatal, right? Because that is definitely a fatal error. We do not want to proceed in that case. All right. So what I'm going to do, I think, let's just go in order here. So the first one I'll move over is the console. So I'm going to snip this out of here. Go to our systems manager, go down here. And I'm just going to paste this temporarily because I know that we're not actually going to have to do all this because we have this stuff here instead. But we are going to need an include here, or a set of includes. So we'll say systems. We'll say include core console. And what we want to do is we want to say systems manager register. We're going to pass along the state. We are going to pass along the type, which is going to be K system type console. The initialize, we're going to say console initialize. The shutdown, we're going to say console shutdown. And console, I don't know if there was I don't think there was a console update. Was there? I don't remember if there was. Initialize, shutdown. No, there wasn't. Okay, so we don't need that. So we'll pass 0 there. And we also do not have configuration for this, so we'll pass 0 there. And we'll say if not systems manager register, K error, failed to initialize, failed to register console system. Okay. Return false. So basically all of this gets replaced with this. Okay. Now, console initialize, the function does not have sort of the same layout as what we've defined as our requirement up here in our function pointer definition. So our function pointer requires memory requirement, U64 pointer, memory void pointer, both of those we have. But it also requires a void pointer to a config, which we do not have. So even though this system doesn't technically require it, we need to adjust it so that it meets that criteria. So all we're going to do is go here to the H file, void pointer config, right? Oops. And we'll go to console.c and add it here as well. Okay, and now that meets that interface there. Let's close some of these other files here. We don't need all these guys open. Not by a long shot. So let's close these, right? All right. So that is the console system, right? That should be... The only other thing we'll have to do is console... Oops. Console shutdown. Oh, that's interesting. We're doing this twice. Okay, not sure why that is, but let's get rid of one of them. And we'll go ahead and replace this with, we'll say, Systems Manager Shutdown, passing along the address of engine state, Systems Manager state. Okay. And then we'll go ahead and get rid of console shutdown. And we can actually... Do we have anything else in here regarding console? We do not. Okay, so we can get rid of that include. We can get rid of this state. And we can get rid of this shutdown. Okay. All right. So that looks pretty good. Looks like Systems Manager is still bleating about something. But I think we're in decent enough shape. We could probably build this now. Looks like we missed something. Non-void function does not... Oh, right. Okay. Return true. Right, we don't actually have that hooked up yet, but that's fine. Let's do... You know what? We don't have a shutdown either. So let's do this as well. We'll say shutdown known systems, right? And we'll go ahead and return type should be void on that. And we'll go down here and basically have our known systems shut down. So we'll say systems, actually we'll say state systems, K system type console shutdown, and then state systems K system type console state, and pass that along, right? And so this is basically what the shutdown code is going to look like for that. Now we can either do it like this, or we can basically create a loop to do it for us. For right now, I'm going to be explicit about doing it this way, right? Let's see. Oh, we are not shutting down known systems. So let's go ahead and do that. Pass along state, so we don't run into any issues there. Looks like we're still missing something here. Incompatible function pointer types. Let's see. Need this to be a little bit bigger. PFN system initialize. Whoa, man, did I spell that wrong? How did I not realize that before? Let's fix that first. Okay. Console initialize. So it's saying console initialize does not fit this. So let's just copy this. Go over to console. And paste this right here. Ah. Return type is different. That would be why. Pretty sure everything else matches up. Yep. Okay. So we'll have to convert this to a B8 and then go to console initialize, return type B8, and we'll just return true. Now what? Oh, right. This should also return true because that's technically not a failure. We're just getting a memory requirement there. Okay, so it looks like we built. Really not understanding why this is still bleating. Let me reload the window real quick. I guess VS Code was just being a bit of a bananas. All right. So let's go ahead and run and see if we broke anything. And it does not look like we have. We'll go ahead and open the console here. Input some rubbish. Yeah, so it looks like our console's working. So that's good. Access violation. Shut down known systems. Okay. What has happened here? State is 0. But why though? Oh, I know why, you dingus. It might help to actually move this to the array. So we set this up in a temporary variable here, and we never actually saved it off to the array. And the only reason that we got away with that was because all of the initialization code set up the stuff that it needed to in the internal static variable, so that it had a state pointer. So we would have found this bug the hard way once we actually stopped using the state pointer afterwards. But anyway, now that we have that, at this point we should be able to do... Do we have one more thing? Did we save off the type to that? I guess we don't really need to. Okay. So what we need to do here is we need to set up the state, and we'll say systems subtype, and we'll set that equal to sys. And now we should have what we need. All right, so we're running just like we did before. And now we exit. So with that, we were actually looking pretty good to go ahead and continue on with this. So we have what we need in place, at least, in order to do the rest of the work on this. So I think from now forward, it's going to be mostly just converting all the systems. So before I do any of that, do any of you in chat have any questions for me? Like I said, I want to keep this interactive, and if anybody has any questions they want to ask, I will try to field them to the best of my ability in chat or here. While you're doing that, so I will double check my engine code here. Let me back off some of this stuff here. So basically we're just going to follow suit with the other systems here. So the next one in line is going to be our KVAR system. Yeah, so let's go ahead and move that. Looks like our KVAR system, again, is a little bit different, so we're going to need to update that to match the new interface that we have. So that just means in this case we're going to add a void pointer to a config that we're not going to ultimately use. but it'll be there for in case we ever do change that. Right, and it already returns type B8, so we should be good on that front here. All right. So the next thing that we should need to do is we can clip this out of here and go back to the systems manager, and we'll go to our register known types, and we're basically just going to follow this pattern through. So I'm just going to copy pasta this kvars. I may want to set up a macro for this actually. Okay, so kvar, and in this case we're going to use, actually we need to include before we do anything else. Include systems. Oh wait, did I put that in core? I might have put that in core. Yeah. Which I guess is fine. So I'm going to minimize this register because that's not going to change. I'm going to, we're going to actually have to change that one here in a minute, so I'll hold off on that one. All right, so the system type is kvar, kvar initialize, kvar shutdown, and I don't think there's a kvar update here either. There is not. So we don't have an update, we don't have a config. So that is all that's going to be required for our kvars. So we can get rid of that. And then we're just going to change this to do the exact same thing. And like I said, we're probably going to wind up doing a loop here, but while we're doing them one at a time, I would rather just sort of make sure that they are acting correct one at a time, which seems like a lot of extra work, and maybe it is, but it's better safe than sorry. So all this shutdown code is going to go away too, which is awesome. Oh, neat. We never shut down the kvar system. That's cool. So we don't know if that works. And this is the other thing that that system is going to prevent, is us having to manually put things in two different places. Here, it just sort of kind of automates a little bit of that process for us. All right, so we've built, we're going to run. All right, and I'm just going to test our kvar system real quick. So kvar add int, call it test, and we'll set the value to 4. Or is it kvar add? So kvar int add? I can't remember the command. Create int. That's what it was. Create int. We'll name it test, and we'll set its value to 5. Okay, so we've done that. Kvar print all. We have that variable. So I'm pretty satisfied that the kvar system is actually working. So we'll go ahead and exit. And we did not get a crash on exit, so the kvar system is converted over. I'll close these console things too. All right, so that is that. We can also, did we remove that out of the state? We did not, but okay. So the next one is going to be the event system. This one will be relatively easy to test. So basically nothing is going to work if this is broken. So I'm going to remove the event system. I'm going to remove kvars out of our includes, but our event system is going to have to stay. Because I can't see us completely removing that out of the engine. Yeah, all right. So we've got that. We'll come down here. And again, our event system initialize actually does not have any kind of configuration, in fact. That's interesting. So what has this actually been allocating this entire time? Because it looks to me, yeah, this doesn't actually even take in any arguments. How did this ever work? Yeah, these two don't match. Interesting. Okay. I guess because this was forward declared but defined correctly, I guess it just does the thing. That's kind of scary. All right, well, let's fix it. This needs a void pointer config. And I'm going to copy these guys. Go over here, drop that there. It looks like shutdown is also wrong. So that should require the state. Okay. That is crazy to me that that has not caused us problems. But there you have it. All right, so that means we can get rid of this. Let's take events. We'll go down here, whoops, to our shutdown. And we're going to get rid of the event system out of here. And our systems manager, we're basically going to do the same thing again for events. Event. Event. Whoops. We need include core event.h. This is going to be event system initialize, event system shutdown, and again we don't have a config or a update for that. So we'll just use this for event system and then shut it down here. Okay. Right. Let's go ahead and build that. What is it bleating about? Oh, let me guess. It probably is return type void. Yep. Okay. So this needs to be a B8. This needs to be a B8. And this needs to return true. And this also needs to return true. Okay. And we'll go ahead and run this. All right. And we know that's working just because our keyboard input worked, right? So I'm pretty satisfied with that. All right, next. Come in here. Basically have all of these left to do. Hopefully this will get a little bit quicker. So job system is next. come down here. Well, job system is not next, actually. Well, it was next in here, but these are apparently are not in order. So logging system is next, so let's get rid of that. Logging looks like it takes in a memory requirement and a state, but not config. So let's go and fix that. Void pointer config. Wait, initialize logging. There we go. So let's get that. It already turns a B8, which is good. So we'll just update the comment there. The config for that is ignored. And it should just be a case of we remove this and come down here and remove. Did we never shut down the logging system either? See guys, this is what I'm talking about. This is why you generally want to write these systems a little bit sooner than this, because that really should be shut down. Yeah, apparently we never did that. All right, cool. So that's neat. Another one. So we'll go ahead and do logging here. We already have the logger, so that's good. Logging. What was it? Initialize logging. And then shut down logging. That doesn't fit the naming scheme of literally everything else we have, though. So let's change it to be consistent. Okay. Looks like it hit the C file there. And here. Okay. All right, so that's logging. We'll go ahead and set the thing here too. So the type is set. All right. Not too surprised about that. Recompile there. Everything uses logging, so. And we can tell the logging is already working. The only thing I question is the shutdown. But looks like that works too. Okay, so that's logging. So we can get rid of these guys. So the next one we're going to do is input system. So input system, same thing, no configuration. So void pointer config. Oops. Want input H. Config. Config ignored. Oh, this needs to be returns true on success, otherwise false. Okay, which means we need to go in here, make this match the interface. So this needs to be returned true, and that needs to be returned true. And we can now get rid of this. We can go up here to the input system and get rid of that. We can come down here to the input system state and get rid of that. Systems manager. Input. So we have include core input. So this is going to be input, input system initialize, input system shutdown, and I think actually this does have an update. It does. So I think our update is actually being called manually. It's called at the end of the frame, and its timing is actually pretty important. So, do I want to change that? I'm not going to change that for right now. But what I am going to do is I'm going to put a to-do in here. Refactor to use system manager update with state, but must be called at end of frame. Because this is so time sensitive, and when it gets called, I'm not going to mess with this just yet. At least not for this pass. I might try changing it later on and seeing what happens, but for right now, I'm going to leave that alone. So the config is not actually used, so this should be input. Oh, and this should be, looks like we forgot to update a couple of those there. Okay, so input system is there. Let's go ahead and also shut this down. All right. I'm fairly confident this is going to work. Yeah. Okay. So that is input. All right. By the way, if you guys out there have any questions, feel free to ask them in the chat, and I will answer them to the best of my ability. But for now, I'm just going to continue on and continue the refactoring. So I guess we'll do the next one. Now, let me see something here. Okay, yeah, so these inputs were registered after these events were registered there. It's fine if we actually wait until all the way to the end. So I'm going to redo all of this. What I was wondering was if the timing of these was important, but it's not. It can actually be moved all the way to the end. So I'm going to put it here. And basically everything that's under here is what we're moving. Okay. So platform system startup. This has a bunch of parameters in it. Looks like we passed an application name, an X and Y, width and a height. So that technically could be our config. That could be all rolled into a configuration object. So I think that's probably the way that I'm going to handle that. So I guess, crap, I've got to refactor this for all platforms. Okay. All right, I guess let's start with Win32. So, well, actually, we really need to start here. So, let's type def a new structure. So we'll say struct platform system config. And I'm going to basically just grab these things here and put them in here as properties. Right? And then here I'm going to say void pointer config. Right? And I guess I might as well move these comments over. Right, because it makes 0 sense not to. I have them all nicely typed out. I might as well use them. Let's see if we can speed this up a little bit, though. So paste these. So we'll do that. That's the additional x. Y is the, it should be here. Width. Why have you done that? Height. All right. Right, and then we can just say here, config a pointer to a configuration structure required by this system. Let's be a little bit explicit here, and we'll name the type there too. So we'll go to platform startup here, and we'll change that to config. Right. Config. Let's see, we don't need, why is this bleating? Okay, I don't know why that's complaining, but whatever. So, what is the first? Let's just build this real quick. So we had here what? Application name XY, width and height. So application name. Here we go. So let's first do platform system config. Typed config equals config casted to this type. So we're just going to cold cast that. And now we can say typed config X, typed config Y, width, height. Did we have application name? There it is. Right. Okay, so that should fix it for that. On Linux, and we're not currently on Linux, we're on Windows, but I'm going to have to sort of guess here. So we're going to do a cold cast here. Let's put this all in one line as well. So we'll do a cold cast there. Here we go. So we have our X, Y, width, and height. And our application name is here. And here. And I think that's probably it. Okay. So we also have to do Mac OS. Let's see, where is that? Here we go. So I'm just going to paste this here. Change this to void pointer config. Put it on one line as we have the other platforms. All right. And then we have typed config. Let's see. Where is our sizing stuff in here? It's been a minute since I've looked at this stuff. Here it is. Okay. So we need that, and that, and application name. It's the only other thing. I think that's the only other place it uses it. So there we go. So that's typed config. All right, so that should be good for that platform. Hopefully those compile. If they don't, put in a bug request, and I will get that fixed on that platform. I'll probably have to test it off the stream later. All right, let's see. So what are the compilation errors we have? This is probably actually exactly what we expect. So platform system config plat config, and we'll just set all that to zeros. And platform engine startup, we're just going to pass I guess the best way to do it is just do it this way. Here we go. So we need that. Let's see, platform config. That's going to be X is this. Y is that. Plat config width is this. Height. So we have application name, so that should all be there. Now we can just pass the address of this thing, right? So the address of platform config, address of platform config. In theory, that should be right. What did I miss? Too few arguments. Platform startup. Oh, right. I took out one of the zeros that shouldn't have been taken out. Okay. So I'm just test running this now. So it looks like, at least it looks like the Windows platform is correct. So this one is a little bit different in how it operates, obviously, because it requires this complex config. And so as far as adding this one, this is something that I hadn't quite thought of. So we need a way to be able to pass like an application config to the systems manager. I'm actually wondering if we should just pass this. Yeah, because we're also going to need this configuration. So maybe we do pass along the application config when we're standing up the system. So that is an engine.h. Do we want to pass that? I guess it kind of does make sense though. So I guess what we could do is forward declare application config. And pass that along. And pass that here. We could include engine.h to get the underlying actual type. And then pass this along here to register known systems. Registered known systems would take that in, and then we'd be able to set up the platform as expected. I think that's going to work. Let's close this input, some of these other files here. Let's close these things. So realistically, this guy would move to our systems manager here. Here we would include platform.h. And we would essentially just do the same thing. So this would be platform. Platform. Do we not have a... What am I missing here? Platform system startup. Okay. platform system shutdown. All right, and then for now, again, we do kind of have an update for this. It's the pump messages, but I don't think we actually want to use that as is. We don't want to use that here. I think we want to explicitly call that still. So I'm going to leave that as is. We do need to get rid of this and change these to pointer types. Right, so that should be change these operators here so that we have that. Startup, shutdown, update, and then config is going to be the address of plat config. And this is going to be platform system, right? Okay, so that's platform system. So we should be able to get rid of this. And then come down here. Oops. And get rid of this. And also our systems manager, we also do need to shut this down as well. All right, let's go ahead and build this. I'm not surprised I missed something. Too few arguments in function call. Systems manager initialize. Oh, right, because I have to pass engine state. Or no, it's, what was it? Game instance. Was it game instance? Yeah, game instance app config. And I need the address of that. What did I miss now? Oh, right. Okay, I have to pass this through. So app config. There we go. Okay. All right, I think we're good to go. So let's go ahead and run this and just see. Yeah. Okay. So it looks like we didn't hook up everything correctly. Let's have a look at our log file here. We really need to fix a lot of these too. Resized. Okay, so I wonder what... I wonder what caused... Make sure I didn't miss something here. Well, that was all that was here. App config. Okay. So I guess let me just put a breakpoint here and make sure that this data is coming through as we expect. Okay, so it is. I wonder what is causing all of that. Context frame buffer width and height is 0. So I wonder what so this is the platform pump messages that I was talking about, but platform system memory requirement. Okay, I guess I'll try removing the platform system memory requirement, because maybe that's... We technically don't need that, right? So... That is bizarre. All my keybinds and stuff still work, but for some reason... So let's think about this for a second. What changed from where I call this here platform system startup, make sure I pass this right. So it should be state type initialize shutdown update, which we don't have, and then config. So I'm passing the address of the config here. So the platform system startup here takes this config, does the whole memory requirement thing, we are using type config here. Just going to copy this real quick. All right, put this back for a second. Put this here for a second. Grab this. Crap, I'm going to have to change all these things back. put all these back. Go to here. Shut that off. So if I stand this up the old way, we still get valid config. But it works. Oh, well, that's expected because I didn't actually add it. So that actually makes sense as to why that failed. So what is the difference between what is being called here and what is being done here? So we just pass along the config, which is what we're doing there. Unless maybe we're not properly passing along the config. I can't see that being an issue though. All right. Sure enough, though, there's some sort of issue with that. That's the bizarre thing, though, is this was actually getting called with the right parameters. It's going to be something stupid. I'm almost positive. Almost positive it's going to be something stupid. All right. Let's just see what this code is actually doing here. So we have do we have anything else called config here? Nope. Let's see. I don't think there's anything down here that's relevant. No, that's all thread creation stuff. Why does this keep saying it's incompatible? Telesense strikes again. So we're not taking that is bizarre. I don't think there's anything else here. This is the only thing that deals with resizes. I wonder what happens if I try and like maximize this. Oh, it's interesting. So that fixes it. So it just does that until I resize the window. What am I missing here? We're doing the same pattern of get the memory requirement, allocate the memory, initialize. But it doesn't like it until I resize. The only thing I'm doing different is passing this app config. Yeah, I was gonna say, I think that's the right type. I spelled it right and everything. Pass that along as a pointer to register known systems. We create this here. We pass along its address. So there's something in here maybe that we're doing wrong. Config. Config is passed twice. Initialize, allocate, initialize. Well, this is definitely an interesting one. This may be one that I have to walk away from and come back to at another point, because I'm just not seeing it. You know what? Just for good measure, let me do a clean and full rebuild. Okay. Yeah, I didn't think that was going to make a difference. I think even if I resize this, it'll probably fix it. Okay. So I think what I'm going to do is I am going to commit what I have, but to a feature branch. So this causes an issue where the swap chain generation fails with a size of 0, 0 until a window resize happens. But why? Yep. All right. So get checkout B feature systems manager and work in progress. Oops. Yeah. Get add dot get commit work in progress feature manager. Part 1. Feature systems manager. All right. Okay, so this is where I'm going to wrap up the stream for tonight. We've gone on for about 2 hours now, and so I think that's a pretty decent session. I'm going to go ahead and have a think on what is going on here. I'm sure it's going to be something stupid. I'm thinking it's probably just a life cycle issue somewhere. Something's being destroyed or going out of scope. So I will think on that, and we will come back to this in the next stream. For those of you who are watching this on YouTube, thank you guys so much for following along. I really appreciate having you guys here. If you have any questions or comments, or you think you know what it is, feel free to put that down in the comments. Although by the time this comes out on YouTube, you guys are probably, I will have already figured that out. But yeah, so I guess I will catch you guys next time. If you haven't already, hit the like button, subscribe, and I will see you guys next time. Thanks.